Okay, here we go, 7.3.1, so chapter 7.3. We learned back in 7.2 that tangents are always perpendicular to radii on circles. We also talked about tangent points that come from outside the circle and what happens there. Here we're going to talk about, in this first one, a common external tangent line. And so what you see that I've drawn here is two circles, right? And they have a common external tangent line. We'll do an internal one next, but external line that goes from E to B to C, and that this line is perpendicular to the radii of circle A and circle D. So that's a common external line. You'll see a couple things down here. I've created this idea called a magic rectangle, which I'll tell you about in a second. We always want to be looking for right triangles because of the fact that radii and tangents create right angles. There are often right triangles that will help solve problems for us. And here's a little word to the wise. Make sure you label the hypotenuse opposite the right angle. And you see up here the problems that we often come across in this section are you're given two pieces of information and you need to find the third. The three pieces of information are often given to you. So you might be given the radii of this triangle, of this circle, right? So circle A may have a radius with circle D, right, which has a different radius. You might be told the length of the tangent segment, which in this case would be from B to C. And so finding that length might be an important piece. And finally, you might be asked to find the distance between A and D. So if you've been given two out of those three, you can always find the other. Here's the quick trick. There's a little bit of a helpful thing to remember. When you have a common external tangent, what you'll notice and remember is that these two lines, these two radii in this situation are parallel because they are perpendicular to the same common external tangent. Why is that helpful? Well, we know from the perpendicular postulate that if there is a point like D, I can take D and slide, and there is a perpendicular that hits this other one over here. Now what you notice is that I have now created what I call the magic rectangle. The radius here is replicated over here. And let's say you've been asked to find BC, right? Let's say that's the big question. How long is the common external tangent? Let's say you've been given that this is, I don't know, 3, and this is, let's say, 5. And let's say you've been told that the distance between these two things is 10, just for fun. And in that case, we have a magic rectangle. I draw the perpendicular. I get 3 over here, which is awesome. That makes this 2. And you'll notice that if I connect A to D, I now have a right triangle in there. What's important and why I make this little piece of a word to the wise, label the hypotenuse. In this triangle, let me just change the color a little bit on this one so that I can show you what I'm talking about. In this blue triangle, you will notice that there is a right angle here, which makes AD the hypotenuse. So in this case, the hypotenuse is that length. And so you're going to fall back on the Pythagorean theorem, and this piece that you're looking for, this length of the common external tangent, is replicated on that part of the triangle. So for instance, if this is x, and that's what I'm trying to look for, I know that x squared plus 2 squared is equal to 10 squared. And you can see, just briefly, why it's important that the hypotenuse is identified. A common mistake is assuming that x is the hypotenuse, because it just feels like it might be, but it's not. And of course, that would change your Pythagorean theorem drastically if x were the hypotenuse. But 10 is the hypotenuse in this case. You know 2, you know, and you're trying to find x. Okay, and there may be other problems where you're given different pieces of information, but creating the magic rectangle, right, which is this thing that is way up here that I've just outlined. Let me just put the magic rectangle in orange, right? This is the magic rectangle. It's created by making it perpendicular to the other radius and going from there, okay? And that's it. Have a great time. Thanks, bye.